Welcome everybody to the Launchpad. This is a very stern test of marketing, of messaging, of slideware. I hope you're all going to be behind everybody here. They've got to get their message across to you in 2 minutes. Any longer than 2 minutes, then I'm going to come up the stairs and we're all allowed to clap them off stage. So hopefully somebody will be misbehaved and we can pull them off. So yeah, 2 minutes for each pitch when we've got about 7 or 8 people here for you. So first of all, I'd like to welcome to the stage Larry Lapides from Synopsys.
Thanks, Andy. I'll try and keep this to 2 minutes here. So first of all, I think most of you know Synopsys. Synopsys addresses the needs of the RISC-V design community, the whole semiconductor community, and you can see all the different markets that we play in here. So with RISC-V, a lot of it is just, well, RISC-V is another processor. It's RTL. Synopsys has been building EDA tools for quite a while. And so here we are, supporting RISC-V. But with RISC-V, because the EDA tools are being used, 90% of the advanced chips are using Synopsys technology. But with Synopsys, with RISC-V, it's more than just the conventional EDA tools. There are actually things that we're doing that are specific to support RISC-V. So we can see here at the beginning, optimizing QOR and productivity, talking about the Fusion Quick Start implementation kits, the Empirus FPM RISC-V fast processor models as reference models both for DV and for virtual prototyping, and then Empirus DV and Sting as a solution for RISC-V processor verification. Move from there into early architecture exploration and software development with, again, another set of tools both for processor exploration and also for SoC architecture exploration, and then down to virtual prototypes, which is now the way to build software for your SoCs. Moving on, we're accelerating software with hardware-assisted verification. And then, of course, with Synopsys, we have the ARC-V processor IP, 25 plus years of delivering processor IP. Synopsys has a number of presentations at the show. There's a list here. It's great. And last, thank you. So hopefully, right on my 2 minutes.
Thank you, Larry. Not bad, 2 minutes 10, we'll let you away with that. So next we've got Rabin Sugumar, co-founder and CEO of Akiana.
Hi, I'm Rabin Sugumar, nice to be here. I'm one of the co-founders of Akiana. Let me do a quick introduction of, okay. I don't hope this doesn't count against my 2 minutes. Are you able to hear me now? Sorry, yeah. Okay, so we just came out of stealth a few months back. So just 5 key points, right? So performance. So the team is a veteran team. We are the team that did the ThunderX2 ARM server chip. This was the first high-performance ARM server chip, went into the supercomputer top 500, was the first ARM server in Microsoft Azure. So the team is a veteran team, has done several iterations of production high-end silicon. We have a very broad product portfolio. We have a variety of cores. We have high-end cores that compete with the high-end of Neoverse from ARM. We have mid-range cores, both out of order and in order. We have low-end microcontrollers. We have coherent and non-coherent interconnects based on the AMBA standard. We have all the support IP like interrupt controllers, IOMMUs. And we can build compute subsystems and deliver it as one subsystem verified and built for a customer, right? So it's a very broad IP portfolio ready for high-end deployment. Verification is one of the strengths of the team. We have lots of test benches, lots of test generators. We spend a lot of time verifying our IP. We also have FPGAs and Palladiums that we run our IP on. So you can actually come to our booth there and see a high-end core running a variety of apps on the FPGA. We target a variety of markets, and we are well-backed. We have a long runway, tier 1 investors, and we are excited to be on this RISC-V journey. Just a little bit on the team. We did the ThunderX2 ARM server chip. That was the first ARM server in the supercomputer top 500, as I said. We were there for 4 years. We came up to 156. And our systems stayed on in several deployments for many, many years. We were also the first ARM server in Microsoft Azure. And we pioneered high-performance ARM servers, I would say. And we are taking that to the RISC-V ecosystem now. Come see our demo. We have 2 demos. One is an out-of-order core, roughly spec in 2006-15, running a variety of apps. It has hypervisor. It has compliant RISC-V vector 1.0 implementation along with encryption. We also have a very wide AI core implementation with a 2048-bit vector implementation. And Graham will be presenting a brief overview of our products in the demo theater. So, thanks.
Thank you very much. Next up for you, we've got Marc Evans, Director of Business Development and Marketing from Andes Technology USA.
Hello, everybody. How are you? So I'm going to gratuitously steal this slide from Dr. Su this morning. We're very proud at Andes to have a good percentage of the RISC-V IP market spanning many different segments from MCU to AI in particular. And I was trying to think, what can I tell you in less than 2 minutes that gives you any detail? And I thought I would go into more of the encompassing product offering Andes has. So not only do we offer the processor IP cores, we offer a pre-integrated platform with basic bus interconnect and low-speed peripherals. We offer tools for extending the processor instruction set correctly. We offer an IDE that helps you profile, do pipeline visualization. We offer our Andes Air and Complete Neural Network SDK. And we also offer a number of boards to help software development get going early. And I think one of the things that certainly sets Andes apart is a really encompassing product portfolio. We span from compact MCUs to high-performance out-of-order processors. And this year, we're undergoing a really rapid product expansion, starting with what Dr. Su announced this morning, the AX46 MPV, scaling up to 16 cores per cluster, expanding the vector length to 2048 bits, adding matrix extensions and boosting memory performance. The AX66, adding Chai and RVA 23. And a big expansion on our automotive product family for ASIL D cores and for an automotive HSM. And finally, coming this year, we'll have high-performance application processors and going into our next generation high-performance computing. Thank you.
Thanks very much, Marc. Next up for you, we've got David Kelf, the CEO of Brecker Verification.
Oh, thank you. Hello, everyone. So you're hearing about a tremendous amount of technology at this conference, and quite a lot of it in the last few minutes. The common thing about all this technology is that it has to be tested really, really thoroughly. And this is the business that Brecker is in. So Brecker provides high quality tests, high coverage tests that are automated and cover a broad range of the requirements for RISC-V processors, the cores, core assurance, application cores, the SOCs, and also coherency, security, power, and other things. And the way we get the kind of performance that we get is by using a technique called test suite synthesis that allows us to go and dive into designs, find corner cases, and really get really, really high coverage, and port these tests across simulation, emulation, post-silicon, and even to virtual platforms. Today, the tests are in use in 15, right as we speak, 15 commercial RISC-V projects, and we're counting that. I think we added like 5 or 6 in the last 2 weeks. They're doing very, very well. And one shout out that we must mention as part of this is Brecker is a leading member of the certification committee, which is a program that RISC-V is now working on to produce a certification stamp for processors. This is really a critical thing, we believe, and what we're we're going to see, I think, is a number of tests from different companies, including Brecker, being used in this technology. Thank you very much.
Well done, minute and a half. Okay, thank you, David. Next, we've got Laura Sartori from Codasip.
Hello. At Codasip, our value proposition is a unique blend of RISC-V processor IP and advanced processor customization tool. With a decade of experience in RISC-V and customization, we have now engineering team across multiple European countries and a sales office located worldwide. Our journey into customization began with a competitive and unique off-the-shelf IP portfolio. We are extremely competitive with L110, which is a small core, best in class in terms of power efficiency. And with L41AS, we have proven capability in achieving product functional safety certification. And we are definitely unique with X730, which is the first commercially available RISC-V application core deploying Cherry memory protection technology. Today, we are very excited to introduce a great addition to our IP portfolio, L730. L730 is a high-quality, high-performance embedded core that meets automotive safety and security requirements to enable up to ASIL-D integrity level. Like all our IPs, L730 offers a high level of configurability to achieve different performance points depending on your software application requirement. Our processors are already superior to most alternatives, but they can be even better if you add your own custom instruction, what we like to call your secret sauce. Here you can see example of energy saving achieved by deploying to our baseline IP processor few common custom instructions, such as CORDIC, FIR, and FFT. From competitive and unique IP to unbeatable one, please come to talk to Codasip technical team. Thank you for the attention.
Thank you, Laura. Next up for you, we've got Dr. Daniele Gregori, Chief Scientific Officer from E4 Computer Engineering.
Thank you all for the opportunity to be here. I am Daniele from E4. E4 is an Italian company, and E4 is specialized on HPC. And we try to use the RISC-V processor for the HPC high-performance computing environment. The Future is the name of the project founded by the Italian Center for Supercomputing, dedicated to the RISC-V system. Here you can see the basic idea of the project Future. Montecimone was the first prototype of HPC cluster we did in 2021. The Future is the extension of the Montecimone cluster and is based on a system with RISC-V CPU and RISC-V accelerator with a PCI board on the same system. The idea is to provide a functional InfiniBand driver for RISC-V system, explore the current COTS offering for server-grade RISC-V chip, and continue to monitor the accelerator market to use for the system we will provide in this project. Here you can see the project that is 12 months long, and we have 4 different work packages. Currently, we are running on the definition of the CPU and the server, and you can see the first prototype in this picture. The idea is to have 4 of these nodes to complete the cluster, 1 front-end and 3 computational nodes. And we want to validate with some standard tests widely adopted in HPC, like HPL, quantum espresso, stream, sparse matrix computation, and we want also to measure the power consumption. The idea is to design and build the driver for the InfiniBand network connection that is mandatory in the HPC environment. And here you can see the team that is dedicated to the RISC-V project. Thank you.
Thank you. So next up, I'm sure you all know him already, we've got Flo from Open Hardware Group.
Hello everyone, my name is Flo. I'm the CEO of the Open Hardware Group, and I have only one slide for you. And in this one slide, I made a few words fat, which I really want you to remember. The first is open hardware, not open HW, open hardware. The next one is CVE2, CVE4, CVA6. That's what you need to know. What it is, it's yet another product portfolio. Don't worry. I will not charge you a lot of money for this. I will give it to you for free. Now, the best thing is, these are CPU cores. They are written in Verilog. We have a complete verification framework, System Verilog 2.0. We have documentation. We have the compilers. We have the real-time operating systems. We are working on ThreadX, automotive real-time operating system right now, and we give it to you for free. How do we give it for you to free? We are a member-based, we are a non-profit. So we are not here to make profit. We are here to promote RISC-V, to enable startups to build based on RISC-V CPUs. That's what we are really all about. So the small one, the CVE2, that's a really deeply embedded, super small computer. The CVE4, like a microcontroller unit, and the CVA6, a lot of people working on it. That is an application-ready core. You can find configuration 1 core, 2 core, 4 core, 8 core, whatever you want to scale. The best thing is, in the open hardware, you're working together with a lot of other companies. So we bring together academic, we bring together industrial, and we are all working together to make this course so you can put them in real commercial applications. We have over 500 million cores shipped. So 500 million maybe don't sound much. We hear 2 billion SoCs this morning, but 500 million in a commercial product of a fully open source product. Everything open source. Go to our GitHub, download it. That's amazing. But the best thing is, you come to the GitHub, you join us, and you're collaborating with other people. Everyone needs a brain. Everyone needs a CPU. And together here, you have the chance to collaborate with other companies. You have the chance to collaborate with the academic. So I already talked to Professor Chen here. He's making a radiation-hardened system. There are other things. And hey, wait. I got more. I got much more.
You did very well, but...
So remember open hardware? Remember CVA6, CVE4? Andy, I can tell a little bit. Okay. Hey, it was great to see you.
Thank you, Flo. Next up, we've got John Ronco from Sci-Fi.
Good afternoon, everyone. So I'm sure many of you are familiar with Sci-Fi already. But for those who aren't, then we were founded just under 10 years ago by Kirsta, Andrew, and Yunsup just after they created RISC-V. Our mission is to be the -- technology provider around the RISC-V space with the broadest portfolio of high-quality proven IP. We've had over 400 design wins, getting a bit ahead of ourselves there, and billions of chips have shipped into the market with our IP inside. Now, it's been a busy couple of months in terms of our products, in terms of lots of exciting product announcements that we've had. Back in the summer, we announced our 4th generation of our Essential products. The Essential products are a series of embedded processors, wide range of different possibilities, lots of configuration options, been used in many different devices. And with the 4th generation, we added new features, new capabilities to enable our customers to do more. We also announced the first products that had both both the functional safety and the cybersecurity certification for automotive, and we were the first IP provider to achieve both of those, which is something we're very proud of. We then announced our P870D, which is our first product that's been optimized for infrastructure. So as well as hitting a new high performance point, we added RAS capability, the ability to scale to many, many core systems, and give what you need for infrastructure. And then lastly, we announced our XM product, which is a new processor for AI. We've enabled customers to build AI solutions with our vector cores for many years, but now the XM solution is where we're providing more of a complete package. So the last thing I want to leave you with is just talk about our Hi5 Premier P550, which is the new development board that went on sale this morning. The first 100 units are available and they're selling fast. So if you want one, then you better be quick. This is setting a new performance point for RISC-V. And it's very exciting. And if you want to come and see it, it's in the developer zone, and come and talk to us and we can tell you more about it. So thank you very much.
Thank you, John. So lastly, we have Roger Espasa, CEO and founder of Semidynamics.
Thank you. Okay, so for those of you that don't know us, we're Semidynamics. We're based in Europe, and we produce RISC-V, surprise, IP, but mostly focus on AI. And in one slide, I'll try to convince you why it's great. Well, you know, our AI, our approach to AI is a little bit different than most people. We have everything merged into one. So we have a RISC-V out-of-order CPU driving a vector unit. The vector unit is also out of order, first in the market, RVV 1.0 out-of-order vector unit. And also the CPU also drives the tensor unit, right? So the tensor unit, again, a first programmable tensor unit, fully programmable, fully RISC-V. And the benefits you get by getting all of that together, right? Oh, the clock is going down, okay. Is threefold. First, because these things are connected together, there's no data movement between them. The other architectures send data from their NPU to their GPU, then to the core. Nothing of that happens. So we call that DMA-free programming. And if you are in software, you know how painful DMA programming is, right? The second thing is that it's a single software stack. It's all RISC-V software. So your IDE, your QMU, your debuggers, everything works because everything is just RISC-V instructions. So you don't have to resort to your teams mixing 3 software stacks together. Then it's scalable. This thing can be replicated as many times as you need, from 1, as shown in the picture, to, you know, the sky is the limit. Tell me how much silicon you have, and I'll tell you how many you can put. And finally, future-proof, because a core is driving these things. I can guarantee you in 6 seconds that 3 years from now, this thing will run whatever the AI guys have invented. So you're safe with us. Thank you.
Thank you. Thanks very much, Roger. So yeah, thank you very much for attending the Launchpad. I think everybody did very well except Florian. So yeah, thank you for your time. Have a good day.